You can find the code for this video in my GitHub page, link in the description. Select the Part 2 branch if you want to write the code for this tutorial yourself, or the Part 3 otherwise. The first thing that we are going to do is to add some platforms to the scene so that we can test the new abilities. But before doing that, let's put in order the hierarchy by creating some empty game objects named after the different categories of objects that we have in the scene. One for the cameras, another for the platforms, and the last one for the characters. Now just drag the game objects into the appropriate category. We can finally create the new platforms. Start by duplicating the platform fast game object and rename it to wall left. Change the X position to -10.5, Y to 0, and the Z rotation to 90. Duplicate the wall left and rename it to wall right. Change the X position to -6.5, Y to 1.5, and the X scale to 7. Now, for the last wall, duplicate the wall right and rename it to wall left. Change the X position to -0.5, Y to 2, and the X scale to 6. The last thing that we need to do is to create two platforms that will act as the ground on top. Start by duplicating the platform fast and adding to its name top left. Change the X position to -16 and Y to 4.5. Then duplicate the top left platform, rename it to top right, and change the X position to 5. Move the character X position to -11.5 and the Y position to 5.5 to place the character on top of the platforms. Finally, drag the newly created platforms inside the platforms category. It's time to get into the code. Go into scripts, checks, and let's rename the ground script to a more generic name, like collision data retriever. Open the script and change the class name to match the file name. Then we are going to make the normal variable public. Rename it to contact normal and make it a field variable, so that we can use it in other scripts and won't show up in the inspector. Same as the onGround variable, we are going to make a field for the wall detection. In the evaluate collision method, we are going to check if the contact normal is above a certain threshold. But this time, we are going to take the X component of the contact normal and use the absolute value of it to get rid of the sign. Then in the onCollisionExit, we reset the value, and finally we make the evaluate collision method public, since we are going to use it in other scripts. Back in the Unity editor, go in the capabilities folder and create a new C# script named wall interactor. This script will be in charge of detecting which interactions should be played when in contact with a wall. Open the script and let's put the code inside the usual namespace. You can change the name of the namespace using this project with one of your choice. Then let's start dividing each wall interaction in its own category. We will start from the wall slide interaction. Create a new float variable that will represent the maximum speed allowed when sliding off a wall, the collision data retriever so that we can actually tell when we are on a wall, the character's rigid body so that we can change its speed, a vector true for the velocity, and a bool so that we can cache the on-wall variable of the collision data retriever. Then in the start method, we are going to get the collision data retriever and rigid body 2D component. Now create a fixed update method. This is where we are going to make all the physics calculations. Let's start by caching out the velocity from the rigid body. Then we are going to do the same for the on-wall variable. To make things tidy, we are going to create a region named wall slide. This is just a convenient way to wrap out the code that falls within a certain category inside a more generic script. Inside this region, we are going to check if we are on a wall, and if so, if we are going down, by checking that the y velocity is under the threshold we created before. If that's the case, we set the y velocity to the wall slide max speed. At the end, we are going to assign back the cached velocity to the rigid body. And that's it for the wall slide. Back in the wall interactor script, we are going to create a public bool field variable so that we can access it from other scripts. Create a new header for the wall jump, and below we are going to create a vector2 variable that will represent the kind of wall jump that we want to perform. The first one will be the wall climb jump, and the second one will be the wall bounce jump. Then we are going to add the controller so that we can retrieve inputs, a bool to cache the on-ground variable of the collision data retriever, and another bool to detect when to perform a jump. Then, since we want to know in which side of the wall we are going to create a float for the wall direction x. In the start method, retrieve the controller component, and then in the update, we are going to set the jump input only if we are on a wall and not touching the ground. In the fixed update, we can cache the on-ground variable and the x component of the contact normal in the wall direction x variable. This last one will have a value of 1 if we are on the left side and -1 for the right side. Then create a region for the wall jump and check if a jump was requested. If so, we compare the negative normal, which will be a vector pointing to the wall instead of outwards, like it usually is, with the movement input. If they are the same, it means that we are pointing to the wall, and we will set the velocity to be equal to the wall climb vector multiplied by the wall direction x to get the actual direction we want the jump to be performed. Then we will set the wall jumping to true and reset the desired jump variable. The same logic will be applied for the second wall jump, but this time we will only check that no movement input is pressed. If so, we set the velocity to be the same as the wall bounce vector and set the other variables like before. Finally, we need to make sure that the wall jumping variable is reset if we are on the wall and the velocity x is equal to 0, meaning no movement input or wall jump was performed, or if we are just on the ground. As you can see now, if you run the game, you'll be able to perform different wall jumps depending on which movement input you are performing while wall jumping. But there is a problem we need to address, which is if we wall jump, the y component of the velocity still increases while on the wall, making this weird slide upward movement. To solve this problem, we are going to use the onCollisionEnter2D method. Use the evaluateCollision method we made public and check if we are on a wall, not touching the ground, and we are performing a wall jump. Then reset the velocity vector back to 0. With this check, if you now run the game, you'll see that the weird sliding upward movement is solved. The last jump that you are going to add is the wall leap jump, and that will be used to go across distant walls. Much like the others, we are going to create a vector2 for it named wall jump leap. Then we'll add an else statement to include the last input case, which is the input that points out of the wall, and we'll assign the wall jump leap vector this time, like with the other variables used before. But there is a problem here. If we try to perform a wall jump leap, sometimes we press the movement input before the jump one, and so we fall from the wall before actually having the chance to wall jump. We can solve this issue by blocking the player's input for a small period of time before falling off the wall. Go in the move script and add a float which will represent the amount of time before we fall from the wall, and another float variable which will be used as the counter for it. Then we will create an object for the wall interactor so that we can retrieve when on a wall and make sure that the collision data retriever object's name is changed accordingly. You might still have the old one in other scripts. Once you have done that, create a region named wall stick, and inside it, check if we are on a wall, not touching the ground and not wall jumping, which means that you are sliding off a wall. Then we check if there is still time left in the counter, and if so, we set the X velocity to 0, blocking horizontal movement. Then we check for movements that point out of the wall and decrease the timer, while when there is no movement, we reset the counter. This way, the movement will be blocked until the counter reaches 0, and reset when on the wall but not performing movements that will get the cursor out of the wall. Finally, to actually make sure that the counter is set, we add an else statement so that the counter is always set back to its maximum value. To put the finishing touch, let's copy the required component attribute from the move class to the wall interactor one. In this video, I wanted to add a bonus section to reward those who have followed so far into the video. And in this segment, we are going to cover the ability to control enemies. Duplicate the player's character, name it enemy and change its color. When you play now, you'll see that you have control over both characters. But let's say that you only want to control the enemy. So you want to switch from controlling the player to the enemy. So we try to set the player's controller to none so that we can control just the enemy, but this gives us a problem. You can see that in the console we now have a null reference exception, and that is to be expected since we have to set the character's controller to none. To solve this problem, you might use an if statement that just checks for null controllers, but we can do better. We can use the null object pattern, which is, in simple terms, an object that produces no actions. In our case, this object will be a controller that does nothing. We can name such controller empty controller. Inherit from the input controller class and implement the methods by returning values that will produce no actions, like false for the jump hold and jump, and 0 for the movement. Remember to create the scriptable object for it, and that's it. With this simple trick, you can now swap controllers without having to worry about incurring into null reference exceptions. Every time that you want to control another character, you just set the empty controller to it.